Hello everyone. Today's my topic is matrices. It is one of the powerful tool of mathematics. It is useful in many fields. It will be used to represent the information in easier form, and it can be accessed easily using the matrices. Now let us see the meaning of matrices. Here matrices is a plural word. Matrix is the singular word. It is the singular one. Matrices will be plural. Now we will see the meaning of matrix. Matrix is nothing but it is the arrangement of numbers in the form of a row or column. So arrangement of numbers means the number which we are arranging may be some information which can be expressed in the form of a row and a column, and each row and column may be having some meaning. Now for example, if suppose we are having one person, say Raju, if Raju has 5 books, if we assume that Raju has 5 books, if I want to represent it in the form of a matrix, I can write it, say 5. Here this number 5 indicates that Raju is having 5 books. Now there is only one information we have written. If suppose if I write Raju has 5 books along with, and suppose he has 4 notebooks. Now how do we write this in the form of a matrix means how this information can be expressed will be, if I write say 5, 4, it means 5 is assumed to be the books, 4 is assumed to be the notebook, means here row indicates a candidate, say a person Raju. Now here the first column may indicate a book, second column may indicate a notebook. So this information we have written in the arrangement of a row and column. So it is easier to access when it is expressed in the form of a matrix. Now if suppose there is another person, say Ramu. If suppose Ramu has 6 books and say 3 notebooks, then we can express this information in the form of a matrix as, we can write 5, 4, 6, 3. So already here we have seen that the first column we are saying books, second column we are saying notebook, first row, now obviously the first row we can say a candidate, say Raju, second row we can say a Ramu. So in this manner information can be expressed in the form of a matrix. Now we will see the actual definition of a matrix. Here matrix is nothing but it is the arrangement of numbers in the form of a row or column. So the numbers which we use in the matrix, we call it as elements of the matrix. So elements of the matrix are nothing but the numbers which are present. Generally the matrices are expressed using capital letters. So we may use A, B, C, etc. Capital letters are used to represent a matrix, and here elements may be a number. So number may be, according to our information, number may be a real number, imaginary number, complex number or integer, or it may be anything. May be positive number or may be a negative number. Generally, the elements can be enclosed within a square bracket, or it can also used this parenthesis. Within this the elements can be expressed. That is, matrix is nothing but we can say arrangement of array, arrangement of numbers, and denoted by capital letters enclosed within a square bracket. Now here element may be positive, negative, real, complex, integer, may be anything. So this is about a matrix. Now we will go further about the matrix. Now we will see order of the matrix. here order of the matrix is nothing but here order of the matrix represent the number of rows and columns. So whenever any matrix is defined, it may be having certain rows, certain column. So we call it as a order of the matrix. Generally, we take small m as number of rows and small n as number of columns. Here, if a matrix is having m number of rows and n number of columns, we call collectively it as order of the matrix, written as m cross n, but read it as m by n. A matrix is of order m by n. For example, if suppose I am having m equal to say 2, n equal to 3, then our matrix will be of the form 2 by 3. It means there is a matrix of 2 rows and 3 columns. So we can write say 2 rows, I will take say A1, say A2. This is 1 row, but we are having 3 columns, so we should have one more element, say A3, then B1, B2, say B3. This will be one matrix of order 2 by 3. While writing we write cross, but while reading we read it as 2 by 3. So this is the order of a matrix. So in general form we can represent a matrix as, generally we can write say A equal to, say A is a matrix, A equal to say Aij of order m by n. It means here Aij indicates row and column. I represents row, j represents column. So first element is treated as first row, first column. So we write it as A11. Second element is treated as first row, second column. So on. So first row, nth column. Now if we come to second row, it will be written as A21, A22, so on, A2n. Similarly, we can write mth row will be written as AM1, AM2, so on, AMN. So it is the representation, general representation of a matrix whose order is m by n. For example, we can write say 2, 1, minus 4, 0, 3, 2. This is one matrix. Next we can have say 3 plus I, 2, 6. So this is another matrix. See, one more we can have. See, 1, 5, 9, say 2.4, 3, 6.9, 7, 8.2, 3, etc. Similarly, we can have many number of matrices. So now we will further go to the next topic in the matrix. We will see types of matrices. Types of matrices. So first we will see row matrix. Say first one, row matrix. Row matrix means if a matrix is having single row, many columns, then we call it as a row matrix. That is, if suppose we are having A equal to say Aij, where row is 1 and column may be many. Aij 1 by n means order will be 1 by n. There may be n columns, but there is only one row. We call it as a row matrix. For example, if we are having say 1, 3, 5, Next we may be having say -1, 4, 9, 6, or simply suppose there is only one element. This is also we can call it as a row matrix, etc. Now similarly we can define column matrix. So column matrix meaning will be there will be only one column and many rows. So we can say that A equal to Aij, and here the order will be m by 1. So for example, here we can write say 1 minus 1, 6. So the order of this is there are 3 rows but only one column, 3 by 1. Now next 4, 8, 6, 9. If we take this, here we can observe how many columns are there. Only one column. Rows are 4. So we can write 4 by 1. So if we write order for the above examples, here 1 row, 3 columns, so it is 1 by 3. And here we can say 1 by 4. And the last one 1 by 1. The same 1 by 1 can be written as column matrix also, because it is also having only one column. Now this is about column matrix. Now if we see rectangular matrix, so rectangular matrix is nothing but a general matrix where the order of the matrix is having m by n, where m and n are not equal. So we call that as a rectangular matrix. That is, if A equal to Aij, whose order is m by n, but m is not equal to n, we call this as a rectangular matrix. Next is square matrix. Now square matrix means, as the name indicates, row and column are equal. We can call it as a square matrix. That is, if we are having A equal to Aij, whose order is m by n, we call it as a square matrix if m equal to n. So example for this we can write 1, 4, 9, say -1, 3, 6, 0, 2, 8. So this is a 3 by 3 matrix, means 3 rows, 3 columns. Similarly we can have 8, 6, 7, 9. So it is 2 by 2 matrix. Similarly we can have n by n matrix. This is a square matrix. Now next we will go to the next topic. Next type of matrix, say fifth one, diagonal matrix. See, diagonal matrix means, so before directly seeing what is diagonal matrix, first we will see, if suppose I am having one matrix, say A equal to Aij, where order is say n by n. So when we are dealing with diagonal matrix, here matrix must be a square matrix. So when we are having a square matrix, then we can define a diagonal matrix. So diagonal matrix, defining diagonal matrix, first we will see, if we are having a square matrix, we can write A11, A12, then it is 2, A13. Say if I take 3 by 3 matrix, say A21, A22, A23, say A31, A32, A33. If suppose I am having a 3 by 3 matrix, means here I have taken n equal to 3. Now if we are having a 3 by 3 matrix, we will check where these are equal, 1 1, 2 2, 3 3. So such elements we call it as a diagonal elements. So these elements where we are having these subscripts as equal, we call it as a diagonal elements. So in a matrix, if we are having diagonal elements and these diagonal elements are present as non-zero and remaining elements are zero, we call it as a diagonal matrix. That is, if we are having a square matrix in which a square matrix is said to be diagonal matrix if Aij is not 0 for I equal to j and Aij will be 0 for I not equal to j. For example, suppose we are having 1 0 0 0 4 9 sorry 0 4 0 next 0 0 9. So here we can observe that first row first column element non-zero, second row second column element non-zero, third row third column element non-zero, but remaining all are zero, so we call it as a diagonal matrix. So next type of the matrix is scalar matrix. Scalar matrix. So scalar matrix is nothing but it is also a diagonal matrix, but the difference is all the diagonal elements are equal. So we can say that a square matrix is said to be scalar matrix if it is a diagonal matrix with equal diagonal elements. That is diagonal matrix with equal diagonal elements. With equal diagonal elements. We call this as a scalar matrix. For example, if I take say 2 0 0 2, it is a scalar matrix. Next, say 5 0 0 0 5 0 0 0 5. Here we can observe that order of the first matrix is 2 by 2, second is 3 by 3. Next, if we take say minus 8 0 0 0 minus 8 0 0 0 minus 8. So this is a scalar matrix. Now next we will go to the next type of the matrix. So next type of the matrix is say seventh identity matrix. Identity matrix. Now identity matrix is, it is a scalar matrix where diagonal elements are 1, or we can also say that it is a diagonal matrix with diagonal elements as 1. That is, we can say a diagonal matrix with diagonal elements 1. With the diagonal elements 1 is called as the identity matrix. Generally, it is denoted by capital I. So, for example, we can write I. So, sometimes it can also be denoted as say I2. Meaning of I2 is it is of order 2 by 2. Say 1, it will be 1 0 1 1 minute. We can write this as 1 0 0 1. Now if we take I, suppose it is of order 3, we can also denote this as I3 equal to. This is of order 3 by 3, so it will be written as 1 0 0 0 1 0 0 0 1. This is said to be the identity matrix. Similarly, I4, I5 we can write. Now we will go to the next type of matrix, that is null matrix. So as the name itself indicates, null means zero matrix, or we can also call it as a zero matrix. So zero matrix means we can say a matrix or a square matrix in which all the elements are zero is called as a zero matrix. So generally it is denoted by capital O, the alphabet O. So we can write O equal to say 0 0 0 0. This will be 2 by 2. Similarly we can have 3 by 3, 4 by 4, etc. So these are the null matrices, etc. So once we will revise what we have seen. So first thing is, matrix is nothing but it is the arrangement of numbers, so which can be arranged in the form of a row and column. So the number of column and row, generally we call it as a order. Then we have seen types of matrices. Here generally there are some 7 to 8 types of matrices are there. Row matrix means a matrix in which we are having a single row. Column matrix means a matrix in which we are having a single column. Next is rectangular matrix, in which number of rows and number of columns may not be equal. Square matrix means in which number of rows must be equal to number of columns. Then next we have seen diagonal matrix. So to see diagonal matrix, one should know diagonal elements. Diagonal elements are nothing but the elements which present at the same number of row and column, that is first row, first column, second row, second column, third row, third column, so on. So that's why we define diagonal matrix as a matrix in which diagonal elements are not zero and other elements are zero, that is Aij is not 0 for I equal to j, Aij will be 0 for I is not equal to j. Next is scalar matrix. Scalar matrix is nothing but it is same as diagonal matrix, only difference is all the elements of diagonal elements are equal. Next we have seen the identity matrix. Identity matrix is, it is a diagonal matrix in which diagonal elements are 1. Next, null matrix. Null matrix is nothing but we can say a zero matrix in which all the elements are 0. So these are the types of matrix. Now we will see equality of matrices. Equality of matrices means when two matrices are equated, how those will be treated. Equality of matrices. So I will take one example. Say for example, we are having a matrix A as Aij of order say 2 by 3. Then next take B is a matrix of order say Bij. Here say this is also 2 by 3, or we will write this as say m by n and p by q, so that it will be easy to compare. So if we write A is a matrix of order say m by n, B is a matrix of order p by q, then A equal to B, if and only if we can say that M will be equal to P, N will be equal to Q. Means this is the first thing, that is two matrices should be equal, means their order must be equal. Second thing is corresponding elements must be equal, that is Aij must be equal to Bij. Then only we can say that two matrices are equal. That is, if A equal to 1, 2, say 3, 4. Then if we take B equal to 3, 2, minus 1, 4. We can observe that first element is not equal to first element, second element is equal to second element, third element is not equal to, or we can say second row first column element is not equal, but second row second column element is equal. That is, it is partially equal, so that's why we say that A is not equal to B. Now if we go to another example, so for example, say A equal to minus 1, 2, 2, 4, and B is also say minus 1, 2, 2, 4, then we can say that A equal to B. First thing is order is 2 by 2, second thing is corresponding elements are same. That's why we can say that both the matrices are equal. Now if we see one example, suppose A is given as say x plus 1, 2, 5, then 9. Say B is given as say 6, 4, 3, 1 minute. Here we write 6, then 2, 5, say 2y plus 1. Two matrices are given. If A equal to B, find x and y. Now here two matrices are given and it is given that both are equal. We have to find x and y. So if we take given as A equal to B, say x plus 1, 2, 5, 9 equal to 6, 2, 5, 2y plus 1. So whenever we say that two matrices are equal, their corresponding elements are equal. Here we can observe first row second column element is 2, first row second column element is 2. Next, second row first column element is 5, second row first column element is 5. It means the other two are also equal. So from this we can write that x plus 1 equal to 6, 9 equal to 2y plus 1. So from this we can write x equal to 6 minus 1, x equal to 5. Next here 2y equal to 9 minus 1, means we can write this as 2y plus 1 equal to 9. So 2y equal to 9 minus 1, 2y equal to 8. So y equal to 8 by 2 equal to 4. So we have got the value of x equal to 5 and the value of y equal to 4. So hence we have obtained the value of x and y by the equality of matrices. So today we will complete this here. We can see the remaining topic in the next class. Thank you.